Okay, heterogeneous membrane. Okay, just to tell you, you can make that yourself. So the basic concept is anion plus cation, then you can make a precipitate, right? So previously, the lanthanum fluoride, it is a precipitate. Actually, that has extremely low solubility. So now you can carry on with that idea as long as you can make that. And this is going to be embedded in a silicon, for example, silicon rubber, which is inert. So you can just make this as a paste before you get to dry. You know, silicon rubber is kind of nice. Then you can shape it to particular circular disc. You know, look real nice and flat. Then now you get the bottom part of the electrode. Okay. So this becomes the disc instead of the crystal. So now you have an electrode. You know, so go back to the previous diagram, and then make this yourself to replace the crystal. Then you will get a functioning electrode. Okay. So for example, then here you know the tool is going to give you precipitate. So the precipitate will be collected, dry, and then mixed with that, and then make your disc and stick to make your electrode. So that becomes ion selective electrode. So your internal solution will need to be sodium iodine, 0.1 molar. Okay. So on exam, I might ask you to come up with a design or reaction to make a certain ion selective electrode. Okay, so if you are here, then you will be able to make it. You sell that. Okay, so here a little philosophy, you know, as a good analytical chemist, you always need to think of certain technique, you know, think of or to see your eyes, to see a technique, you know, any technique, you will have advantages and limitations. So don't just say, okay, ISE is available, then I go ahead and use it. But then you need to realize the limitations and why you pick ISE. So always think, well, previously I have mentioned ISE is most popular, and now is some of the reasons why it is popular. First of all, you need to consider cost. Right, for any technique, that is a consideration. So it is low cost because you already have, most likely, you already have a pH meter available. So all you need to do is just to add more working electrodes, right? So add to that. But then here another calculation though, you know, $150 a piece, so it depends on how many ions, how many electrodes you need to purchase for. So you need to purchase like tens of electrodes, then that can add up. Then other techniques might be more universal to cover all those tens of ions. Okay, so it's always a trade-off. But most people will have just only a few ions of interest to use the technique. Number two, which is highly desirable, which is portable. Nowadays, you have pH meter and electrodes that are pocket size. Okay, so that you can do field work, field analysis. You can get the answer right on the spot. So field work is important, right? Like our first lecture, we talked about if you collect your sample, then you need to consider what containers to use, whether you need to put preservative to preserve the analyte during transportation, and then you need to spike your samples, and then look at the recovery and all that. So if you could do field work, then you can bypass all that, right? Then you get the answer right there. So that is desirable. Next one is simple to use. Like, we all can read the pH meter, right? So you get readings, but then when you get the reading, you need to understand the meaning, right? At least you get readings. Like certain technique, you don't even get a reading, right? So here, at least you get readings, so the definition would be ease of use. You get readings, but then you need to apply knowledge to what those mean. Now, a star to this here, non-destructive. Now, this is a beauty, because a lot of techniques, analytical instrumental techniques are destructive. For example, flame instrument. You look at calcium, you feed your sample into a flame instrument, then your sample is gone, after reading, right? But here, you stick your electrode in solution, after getting a reading, you still have that solution available. So this is something that is valuable, okay, from a cheap technique. Now, this is important, you need to know the limitation. Now, the electron measures just free ions, but then in a sample solution, some of the ion could be complex, such as complex with EDTA. Okay, those are very bulky ions. They move so slowly that they are virtually not free anymore. So keep that in mind. This measure only the free ions. Number two, for the real world sample, the reading is slow. It takes several minutes, to settle, reach equilibrium to get a good reading. And real world samples, there will be a lot of potential interference because they are so complicated. You measure the pH of ocean water, then ocean water has a lot of other cations, like simply sodium plus. You have a lot of sodium plus, you cannot just read the pH of ocean water and then call that done. So keep that in mind. So on exam, I might ask you, give me some advantages and limitations of the technique, ion selective electrode. So if you did not sell that to your friends, then they might answer, what's the problem? I can read the pH meter. So that's it. Let me put that up as a tricky question. Remember. Okay, it turns out that's all I have for today. Any questions?